Hello and welcome everyone. I am Urvishi. I'll be continuing the 10-year PYQ marathon classes. I don't think there is a need to tell you the importance of PYQs. Particularly in CSAT, you cannot afford to miss the PYQs. So, to help you practice the PYQ questions, I have prepared this video. I'll be dealing with the 10-year PYQ questions of CSAT in these videos. They are covered topic-wise. I'll be giving you precise solutions for them and short tricks wherever needed, making the concepts clear. So we'll be beginning with the first video, that is the number system. Since number system is the most favorite topic of UPSC, so I've divided the number system over the 10 years into 3 parts, and we'll be starting with the part 1 of the number system today. So let's begin. Okay, so the first question for the number system in CSAT 2025 is the 18th, that is a 4-digit number n is such that when divided by 3, 5, 6, 9 leaves a remainder 1, 3, 4, 7 respectively. What is the smallest value of n? Now the first thing that you can see is the difference between 3 minus 1, 5 minus 3, 6 minus 4 and 9 minus 7. The difference in all of these is 2. So the common difference is 2. That means n plus 2 will be divisible by 3, 5, 6 and 9. When a number is divisible by 3, 5, 6 and 9, that means it is a multiple of 3, 5, 6 and 9. So the least common multiple of 3, 5, 6 and 9 is 90. This n plus 2, if it is divisible by these numbers, it should be the multiple of 90, that is 90k, where k is a positive integer. Fine. Then n is equal to 90k minus 2. Now what does the question is asking? It is asking the smallest value of n, where n is a 4-digit number. So n should be greater than or equal to 1000. That means 90k minus 2 is greater than or equal to 1000. Further solving this, we get 90k is greater than or equal to 1002, which gives me the value of 11.3. Now since k is an integer, so here k will be equal to 12. So now substituting the value of k into n, the smallest value, we need to find out the smallest value, so we will take the smallest value of k. So substituting this, we get n is equal to 90 times 12 minus 2, which gives me 1078. So your answer will be option number C. Now moving to the next one. Let's read the question. What is the unit digit in the multiplication of the given product? Now the first thing that we can see here is 1, 3, 5, 7, 9 multiplied by and so on till 999. As you can see, all the numbers are odd numbers. Yes, there is a condition that when odd number, any odd number, you take any odd number, if it is multiplied with 5, then it will give the product that will have 5 in the units digit. You take the example of any odd number, you do 3 times 5, it gives me 15. You do 9 times 5, it gives me 45. So for any odd number, when it is multiplied with 5, it gives me a product with the unit digit 5. So the unit digit in this multiplication, all the numbers are odd and they are being multiplied by 5. So the unit digit will be 5. Your answer will be option number C. Okay. Now moving to the next question. That is question number 26. If x is greater than or equal to 4, less than or equal to 8, and y is greater than or equal to 2, less than or equal to 7, then what is the ratio of the maximum value of x plus y to the minimum value of x minus y? Here, when we are asked the maximum value of x plus y, it will be maximum value of x plus the maximum value of y. Now seeing the range here, what is the maximum value of x? It is 8 and the maximum value of y is 7. So the maximum value of x plus y will be 15. Now we will be finding the minimum value of x minus y when it is a product. If we have the minimum value of x minus the maximum value of y, this will give me the minimum value of x minus y. This means, what is the minimum value of x? We have 4 and the maximum value is 7. So the minimum value of x minus y will be equal to minus 3. Now the ratio of these two values being asked. Now the maximum value of x plus 5y to minimum value of x minus y will be equal to, we'll substitute the values, 15 over minus 3, that is minus 5. As we cannot see minus 5 in any of the options, so our answer will be option number D. Now moving to the next one. Okay, let's read the question. The question says, let both p and k be prime numbers such that p square plus k is also a prime number less than 30. What's given to me? That p and k are prime numbers. You should remember the questions. You should break the questions into parts and then try solving it. So p and k are prime numbers. Remember that. And p square plus k is also a prime number, but it is less than 30. Yes. Now what is the number of possible values of k? As you can look here, this p, the maximum value of p will be 5. It cannot be greater than 5. Why? If p square is 25, then 25 plus k is less than 30. This gives me k is less than 30 minus 25. So k will be less than 5. So p will always be less than equal to 5. But if we take p, the next prime number is 7. So 7 square will be 49 and this condition will not be valid then. So p will always be less than or equal to 5. Okay. Now taking the first case where p is equal to 5, what are the possible values of k? As we have seen that k will be less than 5. So the value of k will be 2 or 3, any of this. Now what we need to check is, we need to check whether by substituting k, 2 and 3 we get a prime number for this addition. What it will give me? 25 plus k. Now for k equal to 2, this will give me 27, which is not a prime number. So this cannot be the value of k. Now if k is 3, it again gives me 28, which is not a prime number. Now moving to the next case where p is 3. See, why we are taking p is less than or equal to 5, then why are we not taking p as 4? Because p is a prime number. And what are the prime numbers? 2, 3, 5, 7, 11 and so on. So less than 5 means we have 3 and a 2. So when p is 3, what will be the value of k? That means p square plus k is less than 30. So k is less than 21. Now we'll find out the value of p square plus k for different values of k. If k is 2, 3, 5, 7, 11, then we have 13, then 17, then 19. These are all the prime numbers less than 21. Now substituting the values here, we'll get 11, 12, 14, 16, then we have 20, then 22, 26 and 28. Now what is the condition? That p square plus k is a prime number. So which all values of k satisfy this condition? Only one value. That is k equal to 2 will give me p square plus k equal to 11, which is a prime number. So here only one value of k is possible. Now moving to the third case, we have p equal to 2. Now p square plus k is less than 30 as we know. So k will be less than 26. Substituting the value of p as 2. Now again doing the same thing. For different values of k, we'll find out the values of p square plus k. Now what all values of k will we have here? We'll have 2, 3, 5, 7, 11, 13, 17, 19, 21. Sorry, not 21, because 21 is a composite number and not a prime number. It's 23. Now finding the values of p square plus k for k equal to 2, we'll get 6, 7, then we have 9, then we have 11. For k11 we have 15, then 17, then for k17 we have 21, then here 23, and for k23 we have 27. So here if you look, we have how many values of k for which p square plus k is a prime number? We have this one for k equal to 3, for k equal to 7, for k equal to 13. So here k can be 3, then we have 7 or 13. So how many values of k are possible? 1, 2, 3 and 4. So 4 values of k are possible. So your answer will be option number A. Fine. Okay, now moving to the next one. Let's read the question. There are n sets of numbers, each having only 3 positive integers with LCM equal to 1001 and HCF equal to 1. So LCM is equal to 1001. Sorry, I'll erase it. It is 1001 and HCF is equal to 1. Fine. Now 1001 is the product of 7, 11 and 13. Yes. Now the possible number of sets with the LCM 1001 and HCF 1 will be 7, 11, 13. Yes. It will be a combination of these numbers only, which will give me the LCM 1001. So it will be 1, 13, 77. Then we have 1, 11, 91. Then we can have 1, 7, 143 as well. Then we can have 7, 11, 14. Then we can have 1, 1, 1001. Then we can have 1, 7, 1001. Then we can have 1, 1001. So you can see that there are 8 possibilities we have already made. 1, 2, 3, 4, 5, 6, 7, 8. And there are many more combinations of these numbers 7, 11 and 13. If we do not see the if we see the unordered set, it will give me, ordered set will give me 36 sets of such pair. So there are more than 8 sets of numbers which will give me the LCM as 1001 and the HCF equal to 1. So your answer will be option number D. Now moving to the next one, we have, let's read the question. Let PQR be a 3-digit number, PPT be a 3-digit number and PS be a 2-digit number where P, Q, R, S, T are distinct non-zero digits. Further, there is a relation given between PQR, PS and PPT. If Q equal to 3 and T is less than 6, then what is the number of possible values for R and S? Now, such type of questions, generally we find them difficult. So how to solve? What's the process for solving them? You break the question into parts and you just go step by step. Fine. So what is the first thing that you can read in the first sentence? It says PQR be a 3-digit number. So you simply write PQR is equal to 100P plus 10Q plus R. Yes. Then PPT is also a 3-digit number. Again we will write PPT is equal to 100P plus 10P plus T, which will give me 110P plus T. Yes. Then moving on with the question, we have PS be a 2-digit number. Then PS will be 10p plus s. Now we have written the expanded form. These are the expanded form of the numbers. We have written the expanded form of all the numbers. Now we have now the question says P, Q, R, S, T are distinct non-zero digits. None of them is 0. Further, PQR, there's a set relation given to me. PQR minus PS is equal to PPT. Now replacing this equation with the expanded form, we can get 100p plus 10q plus r minus 10p minus s is equal to 100p plus 10p plus t. Now solving it, what we will get? We will get 90p plus 10q minus s is equal to 110p plus t. So this will give me 10q minus s is equal to 20p plus t. And we have left the r, so I'll write the r by mistake here, and I'll write the r here because we had a r here. So on further solving, we get r minus s is equal to 20p plus t minus 10q. It is given to me that q is equal to 3 and t is less than or equal to 6. Here it's given in the question. Okay. Now what are the possible values of p? The possible values of p are 1, 2, 3. It cannot take the value 3 because q is 3 and p, q, r, s, t are distinct non-zero digits. So it will be 1, 2, 4, 5, 6, 7, 8 and 9. Because they are the digits of the numbers, so they cannot exceed the value 9. Okay. Now we'll move to the next page. If p equals to 1, then r minus s will be equal to, we'll substitute the value of p as 1 in the equation. The equation was r minus s is equal to 20p plus t minus 30. So we'll put the value here, substituting the value of q as 3 here. So it will be r minus s will be 20 plus t minus 30. So r minus s is equal to t minus 10. Now what are the possible values of t? T can take the values 2, 4 and 5. 1 is p, 3 is q and t is less than 6 given in the question. So here r minus s will be equal to minus 8. For t equal to 2, here s will be equal to 9 and r is equal to 1, which is not possible because p is 1 and they should be distinct. Now r minus s will be equal to minus 6 for t equal to 4. Now what is the value of s and r that will satisfy this? R and s can take the value of 1 and 7, then 2 and 8, then 3 and 9. This is not possible. Why? Because p is also 1. This is a valid solution. This is not a valid solution because q is 3. Here p is 1, so it cannot be the solution. Here q is 3, so it cannot be the solution. Now if r minus s is equal to minus 5, if we take t as 5, then what will be the value of r and s? Possible values of r and s, it can take 1 and 6, or it can be 2 and 7, or it can be 3 and 8, or it can be 4 and 9. This cannot be. Why? Because p is 1. This can be the solution. This again cannot be the solution because q is already 3. This can be the solutions. So how many ticks can we see? 1, 2 and 3. Fine. Now this was the solution for p equal to 1. Now if we see for p equal to 2, r minus s will be equal to 40 plus t minus 30. We'll substitute the value of p in this equation. So r minus s will be 10 plus t. Okay, now r and s are distinct numbers. So when r is a distinct number, so the possible value or the possible range of r minus s would be minus 8 to 8. Why? Because r is greater than 0 and less than or equal to 9. Same is the case for s, because they are the digits of the number, but they are distinct. So this is the possible range of r minus s. Now for p equal to 2, you can see that this range is exceeding. If we take t as 1, r minus s will be 11, and t is less than 6. For all the values of t, r minus s would be greater than the possible range. So p equal to 2 will not give me the answer. So how many possible values of r and s have we seen? We have seen 1, 2 and 3. So there are 3 possible values of r and s which will satisfy the question demand. So what will be your answer? Answer will be option number B. Okay, now moving to the next one. See, these type of the questions, the question that we see before this, these type of questions are a bit tricky, so I would suggest you do them at the last when you have time left. And when you are attempting such questions, break the questions into parts and then attempt it. Otherwise you will get confused in what is the question asking, what is the demand, and what are the needs of the question. You won't be able to fulfill them. Okay, so the next question is, what is the maximum value of n such that a product is given is divisible by 35 to the power n? Now first of all, 35 to the power n is nothing but 7 and 5 to the power n. Yes, so the product is given as this. If we find out the factors of each one of the numbers, it will be 343 is 7 cube, 385 is 5 times 7 times 11, 1000 is 2 cube multiplied by 5 cube, 2401 is 7 to the power 4, and 777 is 7 and 111. No need to further factorize it and waste your time in the exam. Why? Because we are concerned about the factor of n and 35, and definitely this 4 times 1, that is 1111, is not a factor of either of them. So do not waste your time by factorizing this. Now our main target is to find out the factors of 7. Factors of 7 are how many powers? Highest power of the factor of 7 here in the product is 10, and the highest power of the factors of 5 is 4. So when we have to see the combination of 7 times 5, if 7 is 10 times and 5 is 4 times, then how many can we make? We can do like this. So it is 35 to the power 4. Yes, it will have this 35 to the power 4. That means the maximum value of n for which this product will be divisible by 35 to the power n will be 4. So this product will be divisible by 35 to the power 4. Fine. Okay, I hope it's clear to you. Next, move to the next one now. If n square is a very long number is given to you and they are asking how many digits does the number n have. See, it's a very easy question. The only thing that you should know for this question is, if you multiply 11 times 11, it will give me 121. If you multiply 3 times 1 with 3 times 1, you will get 1, 2, 3, 2, 1. If you do 4 times 1 and you multiply with itself, it will give you 1, 2, 3, 4, 3, 2, 1, and this goes on. So read the question carefully. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then backwards. If we had 4, we were counting till 1, 2, 3, 4, and then backwards. So using this pattern, we can say that if we have 1 9 times and we multiply with itself, then we will get 9, 8, 7, 6, 5, 4, 3, 2, 1, the number given in the question. So this pattern is very important. Please do remember this pattern. Your answer will be option number B, that is 9 digits are there in the number n. Okay, now moving to the next one. Let's read the question. If n is a natural number, then what is the number of distinct remainders of 1 to the power n plus 2 to the power n when divided by 4? See, when n is a natural number means n is greater than 1 or equal to 1, but n is not equal to 0. Now 1 to the power n plus 2 to the power n is divided by 4, and we need to find out the remainder. Using the remainder theorem, we can write that it is this plus remainder 2 to the power n over 4. Now 1, if it multiplied by n times, it will just give me 1. So it is basically 1 over 4 plus remainder of 2 to the power n over 4. Now we'll look separately for these remainders. Remainder 1 to the power 4 will always give me the remainder 1 plus remainder 2 to the power n over 4. Now if you substitute the value of n as 1, it will become 1 plus remainder of 2 over 4. What is the remainder of 2 over 4? It is nothing but 2. So it will give me 1 plus 2. So the remainder will be 3. Now if n is 2, it will be 1 plus remainder of 2 square by 4. 2 square is nothing but 4. So this will give me the remainder as 0, and the final remainder would be 1. Now if n is 3, it will be 1 plus remainder of 2 cube over 4. Again, it will give me the remainder 0. So it will be 1 plus 0, and the final remainder will be 1. If you take any value of n, like n, 4, 5, and so on, then you will always get the remainder as 0. Why? Because it has a factor of 2 square. Fine. So how many values, how many distinct remainders can we see? We can see only 2 distinct remainders, that is 3 and a 1. So how many remainders can we see? 2. Option number C will be your answer. Okay, now moving to the next one. The question reads, let P equal to QQQ be a 3-digit number. What is the HCF of P and 481? So first thing that we will do is, we will write the expanded form of this number. Can we write like this? 100Q plus 10Q plus Q. So it will be 111Q. Now, if you look carefully, this 111 is a factor, has the factors of 3 and 37, and you can write it as like this. So the value of P will be 3 times 37 and a Q. Now the next number is 481. 481 is a multiple of 13 and 37. So what will be the HCF of P and 481? The highest common factor, you can see it is 37. You have a 37 in 481. You have a 37 in P. So the highest common factor will be 37. So your answer will be option number C. Fine. Okay, let's proceed to the next one. Let's read the question. The 5-digit number PQRST, all distinct digits, is such that T is not equal to 0, P is thrice T, S is greater than Q by 4, while q is greater than r by 3. How many 5-digit numbers are possible? So we will write now, as I've already told you, such questions we will break them into part, we'll do step by step, then that will be easy for you to solve. It's a 5-digit number, nothing is coming out of this, and this t is not equal to 0. That is the important condition. P is thrice t, that is p is equal to 3t. S is greater than q by 4, that means s is equal to q plus 4. And q is greater than by r by 3. So q is equal to r plus 3. And t is not equal to 0, we'll also write it here. So if we put the value of q as r plus 3, so s will be equal to r plus 4. Fine. Now when t equals to 1, what will be the value of p? P will be 3. T cannot be equal to 0, so we'll take t as 1 and we'll find out the value of r, q and s. What will be r if r is 0, 1 and 2? Why will r be less than equal to 2? Because s is equal to r plus this is 7. It was my bad. It is q plus 4. When we are doing r plus 3 and substituting the value of q as r plus 3, we will get r plus 7 and not r plus 4. So when s is equal to r plus 7 and if r is greater than 2, that means if r is 3, that means s is 10, which is not possible. Why? Because s is the digit of PQRST. Yes. So s will have to be less than or equal to 9. For that, r should be less than equal to 2. That is why here we will only take 0, 1 and 2 as the value of r. So if we find out the values of q, it will be 3, s will be 7. Here it will be 4, it will be 8. Q will be 5 and it will be 9. Now this is not possible as p is 3 and we have been given that they are the distinct digits. Here it is not possible because t is equal to 1. This is possible. So we will circle it and we'll mark it as 1. This is the one possibility. This will give me the one 5-digit number possible. Now, if we take t as 2, p will be 6 because p is 3 times t. Now here also we will do r will be 0, 1. R will not be 2 because t is equal to 2 and r cannot be greater, cannot be greater than 2. So r, q and s will find out the values of this. It will give me 3 and a 7, 4 and a 8. So both the values are possible. So we till now how many numbers are possible? 3 5-digit numbers are possible. Now moving to the next one. If t is 3, p is 9. Again we'll do r, q and s. We'll find out the values. It is 0, 1 and 2. R cannot be greater than equal to 2. Greater than 2, sorry. So it will be 3, 7, 4, 8, 5 and 9. P is 9 because t is equal to 3. P is equal to 3t. So 3 3s are 9. So the value of p is 9. 2, 5 and 9. This cannot be the value of s because already p is 9. So we have two possible digits, two possible numbers as well. So this is the fourth possibility. This is the fifth possible numbers. Now, can t be equal to 4? No, t cannot be equal to 4 because p is equal to 3t. So if t is 4, it will give me 12, but p is a digit, a single digit less than 9. So it is not possible. So value of t equal to 3 is the only last possibility. Now we will count the how many total number of 5-digit numbers possible. It is 1, 2, 3, 4 and 5. So your answer will be option number C. I hope this is clear to you. Now we'll move to the next one. What is the remainder of A sum is given to me when divided by 6. Okay, now we will use the remainder theorem here. The remainder of q plus 4 plus 5 and so on till 9 to the power 100 over 6. If we use the remainder theorem, it will be remainder of this plus remainder of 9 to the power 4 over 6 and so on to remainder of 9 to the power 100 over 6. Now what will be the remainder of 9 cube over 6? It is 3. Remainder of 9 to the power 4 over 6 is 3. Here if we see the remainder of 9 to the power 5 over 6, it will be 3. So for all such values, you will see that the remainder is 3. Right? Now, what does the remainder theorem says? Until and unless you get a remainder which is less than the divisor, that is 6, you will not stop finding the remainder. So your final remainder will be remainder of this divided by 6. Now this 3 is coming how many times? 100 minus 2 times, that is 98, because we do not have the power of 1 and 2, so it is 98 times this 3 is appearing. So it will be remainder of 3 times 98 over 6, which is nothing but the remainder of 294 over 6. And what is the remainder? It will be 0. So the remainder of this is 0. That is your answer number, option number A. Okay, now moving to the next one. What does the question say? It says there is a set of questions. Let P, Q, R, S be the distinct non-zero digits. They are distinct non-zero digits. If this product is equal to R, R, S, S and P and values of Q are given, then what does Q equals to? Now two statements are given. Now we have to find out. The question can be answered using which of the statement, or can we find out the question without using the statement? So first we will try finding the answer without using the statement. So what is given to me? It is given PP multiplied by PQ is equal to RRSS. If we use the expanded form here, it will be 10P plus P multiplied by 10P plus Q, which is equal to 1000R plus 100R plus 10S plus S. See, this expanded form of the numbers is very important. This we have done in our lower grades, but the usage of this you can see in your UPSC exams. Yes? So it will be 11P multiplied by 10P plus Q equal to R plus 11S. Now further solving, we'll get P 10P plus Q equals to 100R plus S. Yes, and the question says that P is less than equal to 3 and Q is less than or equal to 4. Now if we take P equal to 3 as the first case, then substituting the value here, we'll get 30P plus Q equals to 100R plus S. So 3Q will be equal to 100R plus S minus 90. And Q is less than or equal to 4 if R is 1, S is 2, then Q is equal to 4. The condition is satisfied for these values. And now for the second case, we have P equal to 2. It will be 2 times 20 plus Q equal to 100R plus S. So 2Q will be equal to 100R plus S. But we can, if we substitute R as 1 and S as 2, then the value of Q will be greater than a one digit number. So it is given q is less than or equal to 4. So here no possible value is there. We cannot find a solution here. Now if we have p equal to 1, it will be q will be equal to 100 r plus s minus 10. Here also q should be less than or equal to 4, which is not possible substituting the values, as you have a factor of 100 here. So again no possible solution we can get. But for p equal to 3, we got the value as q equal to 4, r as 1 and s in 2. Now this answer we got without using any of the two statements that is given. Though we arrived at the statements like r is 1, s and 2, but we did not use the two statements to arrive at the solution. So we can say that this question can be answered even without using any of these statements. Got it? We arrived at these statements, we have concluded that these statements are correct, but while solving we did not use these statements. So answer will be option number D. Now moving to the next question. Let's read the question. Similar pattern, a question is given to me, two statements are given and we need to find out the correct sentence. Is p plus q whole square minus 4pq, where p, q are natural numbers, positive? Now if you look carefully, p plus q whole square minus 4pq. Do you know the algebraic identity of a plus b whole square? It is p square plus 2pq. I can use that identity here, plus q square. It's a very basic algebraic identity. So it will be p square minus 2pq plus p square. Again, I can see that it is p minus q whole square. Now p minus q whole square is a square of a number. Can a square of a number ever be negative? No. The square of a number, the square of any number will always be positive. It will always be positive irrespective what is the number inside. So without using any of the statements, again we have find out that the equation given to me, the statement given to me in the question is positive. So the question can be answered even without using any of the statements. Your answer will be option number D. Okay, now moving to the next one. Let p plus q is 10, where p, q are integers. The maximum value of p and q, when this is the value 1 and value 2 is the maximum value of p multiplied by q, and when the condition is given. Okay, so first we will focus that p plus q is 10. Now we will focus on the value 1. It is given as the maximum value of p times q when p and q are positive integers. So if p plus q is 10, what all the values of p and q can we have? Possible values we can have 1 is 1 9, then 2 8, then 3 7, then 4 6, then 5 5, and the same numbers will repeat themselves. Yes, so these are the values of p and q possible. Now what is the maximum value of p and q? If p is 5, q is 5, it will give me the maximum value. So maximum value of p and q will be 5 times 5, that is 25. Now what will be the value of the second one? It says the maximum value of p multiplied by q when p is greater than minus 6 and q is greater than or equal to minus 4. That means p and q are greater than 0 here also. Yes, so basically it is the one and the same thing. P and q, one and the same thing. So the maximum value of p and q here also will be 25. So value 1 is equal to value 2. Your answer will be option number C. Okay, now moving to the next question. Let's read the question. Let x be a real number between 0 and 1. Which of the following statements is correct? And two statements are given to me. X is a real number that lies between 0 and 1. Now, if you have such questions where only x is given to me, we can substitute any value of x satisfying the condition. So, for example, here, let's take x equal to 1 over 4. And then we'll find out whether 1 is correct or 2 is correct or both are correct, which satisfies the condition. Now, the first one is x square is greater than x cube. Now, we'll put the value of x as 1 by 4. If it is, and we'll check whether it satisfies this, it is 16 is greater than 1 over 64. So, it is true. This statement is true. Now, the second one is x is greater than root over x. X is 1 over 4 is greater than 1 over 4. It will be 1 over 4 greater than 1 over 2. Is it correct? No, it's not correct. It is false. This statement is not correct. So, what will be your answer? Only one. Only this is correct. Your answer will be option number A. Clear? Let's move to the next one. The difference between any two natural numbers is 10. What can be said about the natural numbers which are divisible by 5 and lie between these two numbers? Let the natural numbers be x minus y, x and y, and the difference, that is x minus y, is 10. Now, there are many solutions for this. We'll write some of it, like you have 20 and a 10, 30 and 20, 15 and 5, then you can have 13 and 3, then you can have 40 and 30, because no upper limit is given to you. So there are many solutions for this x minus y equal to 10. Now, in 20 and 10, you have a 15 which is divisible by 5. Only one number is there. For 30 and 20, you have 25. Again, only one number. Same is the case here. But when you look, when 3 and 13 is there, you have a 10 and you have a 5. So you have two numbers divisible by 5. So the question is asking what can be said about the natural numbers which are divisible by 5 and lie between these numbers. So for most of the cases it is 1, but there are cases where it is more than 1, that is 2. So there is only one such number? No. There are only two such numbers? No. There can be more than one such number? Yes. So answer will be option number C. Because there are chances when it is having only one such number, there are chances when it is having more than one such number or two such numbers, right? Okay, now moving to the next one. How many consecutive zeros are there at the end of the integer obtained in the product? A product is given to me. The first thing that you should know is the consecutive zeros at the end is equal to number of times we see the factor of 10 in a number, then that many zeros will be there in the integer. Now given 1 square times 2 to the power 4 multiplied by 3 to the power 6, 4 to the power 8 multiplied by 25 to the power 50. This is the product that has been given to me. Now, as you can see that the factor of 10 is determined by the factor of 2 and 5. So, we will count the factors of 2 in this product. How many factors of 2 can you see? You can see it is 2, 4, then you have an 8. So if you look carefully and you understand the question, then you can see is that the factors of 2 will be greater than the factors of 5, because we have more even numbers than we have for the 5 multiples of 5. So if we find out just the factors of 5, then that will give me the consecutive zeros at the end. So our main target is to find out the number of factors of 5. How many are there? It is 5 to the power 10, 10 to the power 20, then we have 15 to the power 30, then we have 20 to the power 40, then we have 25 power to 25. Right? Now this 25 is nothing but 5 square to the power 25, which can be written as 5 to the power 50. This is 25 to the power 50. So it is 5 square to the power 50, it is 5 to the power 100. Yes? Now, number of factors of 5 will be, if the bases are same, then the powers are added. When you have 5 squared multiplied by 5 cube multiplied by 5 4, this is an example, then the powers will be added. That will be give me the total number of 5 factors. So the same thing we will apply here. So the total number of factors of 5 will be 10 plus 20 plus 30 plus 40 plus 50 plus 100, and it will give me 200. So the total number of consecutive zeros are the number of factors of 10, which is 200. So zeros will be 200. Your answer will be option number D. Okay, now moving to the next one. A sum is given to me. It is divisible by which of the numbers is being asked. So we'll start solving. It is 222 to the power 333 plus 333 to the power 222. So we have, can I write it like this? I'll take this 111 outside and I'll write it like this. If this is multiplied with this, plus 3 to the power 222 multiplied by 1 to the power this. Now taking the common factors outside, we have this multiplied by this is left in the brackets. Now this 111 is nothing but a multiple of 3 and a 37 to the power 222, and here we can write the same thing inside the brackets. Now if we look carefully, we see that this will always give me an even number, this will give me an odd number. And we know that when we add even plus odd, we will get an odd number. So this entire product, that is this one, will be odd. So it won't be divisible by 2. For a number to be divisible by 2, it should be a even number. Odd numbers are not divisible by 2. So what are the factors that are left? 3 and 37. So this entire sum will be divisible by 3 and 37 and not by 2. So it is divisible by 3 and 37 and not by 2. So which option satisfies this? Option number B, 3 and 37 and not 2. So your answer will be option number B. Now moving to the next one. Let's read the question. What is the rightmost digit preceding the zeros in the value of 30 to the power 30? Now this 30 to the power 30 is nothing but 3 times 10 to the power 30, which is equal to 3 to the power 30 multiplied by 10 to the power 30. So this will give me the number of zeros. So this product will have 30 zeros, and this will give me the rightmost digit preceding the 0. Now if we see the cyclicity of power of 3, we see 3 to the power 1 is 3, 3 square is 9, 3 cube is 27, 3 to the power 4 is 81, 3 to the power 5 is 243. So you can see it follows the cyclicity of 4. So what will be the unit digit of 3 to the power 30? It will be the unit digit of, wait, let me just erase it. Yeah, so unit digit of 3 to the power 30 will be equal to unit digit of 3 to the power remainder of this 30 divided by the cyclicity, that is 4. So if you solve it, it will be unit digit. What is the remainder of 30 over 4? It is 2. So it is basically the unit digit of 3 square. And what is the unit digit of 3 square? It is 9. So the unit digit of 3 to the power 30 will be equal to 9. And 9 is option number D. So D will be your answer. Okay, I hope it's clear to you. Now we'll move to the next one. Let's read the question. The question says 421 and 427 when divided by the same number leave the same remainder 1. How many numbers can be used as divisor in order to get the same remainder 1? Okay, now when 421 and 427 they are leaves a remainder, same remainder 1 when divided by, say, the divisor D. Fine. When divided by D, D we are taking as the divisor. So if they are leaving the remainder 1, can we say that 420 and 426 will be divisible by D? If they are leaving one remainder, then if we subtract 1 from each number, 420 and 426, then they will be divisible by D. Now this 420, if we find out the factors, it is 2 square multiplied by 3 multiplied by 5 multiplied by 7. This 426 is 2 times 3 times 71. Now what are the HCF? What is the HCF? That is the highest common factor. The highest common factor here is, for these two numbers, it is 2 and 3, that is 6. So what are values can D have? D can have the values or the factors of 6. What are the factors of 6? We have 1, 2, 3 and 6. So the possible values that D can have is 1, 2, 3 and 6. Now look carefully. Can D be equal to 1? No, D cannot be equal to 1 because in the question it says 421 and 427 leaves remainder 1 when divided by D. So the divisor should be greater than the remainder. So D cannot be equal to 1 here. So what are the possible values of D that we can have? That is 2, 3 and 6. So total 3 values are possible. The divisor, number of how many numbers can be used as divisor? 3 numbers can be used as divisor to get the remainder 1. So your answer will be option number C. Let's move to the next one. Okay, let's read the question. Consider the following statements in respect of the sum s equals to x plus y plus z, where x, y, z are distinct prime numbers, each less than 10. And 3 values have been given. We have to find out which is correct. First of all, we will write s is equal to x plus y plus z. Now the question says x plus y, z are distinct prime numbers less than 10. So that means x, y and z will belong to, they can be either 2, 3, 5, 7. Can they be 11? No, because they are less than 10. So only till 7 they can have the value. And s, they can have the value only this. Now the first condition will assume x, y and z is equal to 2, 3 and 5. Then what will be the value of s? S will be 10, that is the unit digit is 0. Now the second condition is x, y and z is 3, 5 and 7. So here s will be equal to 15 and the unit digit is 5. Now the third case can be when x, y and z is equal to 5, 7 and 2. So s is 14. So the unit digit is 4. I'll write the fourth one here. The fourth condition is x, y, z is equal to 2, 3 and 7. So here s is equal to 12 and the unit digit is 2. These are all the possible combination of x, y and z from the given set, that is 2, 3, 5 and 7, because they have to be less than 10 and they have to be distinct prime numbers. So if we can see the unit digit of s can be 0. Yes, it can be 0 as in the case of first. So yes, it is correct. The unit digit can be 9. No, we do not see a unit digit 9 in any of the conditions. So this is wrong. The unit digit of s can be 5. Yes, it can be 5. So only 1 and 3 are correct. So your answer will be option number C. Now moving to the next one. Let's read the question. Let x be a 2-digit number and y be another 2-digit number formed by interchanging the digits of x. If x plus y is greatest 2-digit number, then what is the number of possible values of x? Now first of all, let x be 10a plus b, where a and b are natural numbers from 1 to 9, 0 to 9, whole numbers. And y is 10b plus a. Can a and b equal to 0? I said a and b can be whole numbers, but can they be 0? Give it a think just for a second. A and b cannot be equal to 0, because if they are equal to 0, then x and y will not be 2-digit number. So value of a and b will be greater than or equal to 1. It can take any value greater than or equal to 1 but not equal to 0. Now we need to find out the greatest 2-digit. Okay, it says we need to find out the number of possible values of x if x plus y is the greatest 2-digit number. What is the greatest 2-digit number? 99. So if x plus y is 99, this is the greatest 2-digit number. So we'll put the values here. It is 10a plus b plus 10b plus a equal to 99. That is 11a plus 11b is equal to 99, or we can say a plus b is equal to 9. We have seen that a and b cannot be 0. Now what are the possible values of a and b which will satisfy this equation? It is 1, 8, 2, 7, then 3, 6, then 4, 5, then 5, 4, then 6, 3, then 7, 2 and 8, 1. So we have how many values? 8 possible values. 1, 2, 3, 4, 5, 6, 7 and 8. 8 possible values we have. Now some of you would ask me, why have I taken 4 and 5 and 5 and a 4? Because when I take 4 and 5, the number x is 45, but when I take 5 and 4, the number x is 54. So we have different numbers. That is why we have taken 4, 5, 5, 4, 3, 6, 6, 3. That is the reason why, because they form different 2-digit numbers. So your answer will be option number D. Okay, now moving to the next question. Let's read the question first. Let PQR be distinct distinct positive integers, let PQ be odd and RS be even. And following statements are given, we need to find out which is correct. Now for such questions, you can assume the value of P, Q, R and S. That will be very helpful. So just satisfying the condition, but the only thing is you should remember the condition, and satisfying the condition you can assume a value and then substitute the value of P and Q in the questions. Like here it is said that P and Q are odd numbers, R and S are even numbers. So let's assume that P is 3, Q is 5, both are odd, R is 2, S is 4, both are even. Now what is the first statement given? P minus R whole square is Q minus S. Now we will substitute the values of P, Q, R, S in this. It will be 3 minus 2 whole square, 5 and a 4. So it is giving me 20, that is even. So that means this statement is correct. Now we'll assume this. Now we'll check for the second statement. It says Q minus S multiplied by Q squared S. Again we'll substitute the values. We would get 5 minus 4. And what is Q? Q is 5, that is 25. And here we have a 4, so it will give me 100, which is even. That means this statement is correct. Now what is the third statement? Q plus R whole square multiplied by P plus S. Again the same thing, we'll substitute the values. It will give me 5 plus 2 whole square multiplied by 3 plus 4. It is nothing but 7Q, which is 343, which is an odd number. So this statement is also correct. Now all the statements are correct. That means your answer will be option D. 1, 2 and 3, all the statements are correct. Okay, now moving to the next one. Let's read the question first. 3 numbers x, y, z are selected from the set of first 7 natural numbers. X, y, z are selected from the first set of natural numbers such that this condition is satisfied. How many such possible distinct triplets are possible? Now the first thing that we notice is that the x, y, z belong to 1, 2, 3, 4, 5, 6 and 7. These are the first 7 natural numbers. So x, y, z can take up all values only from this set. Now the condition says x is greater than 2y is greater than 3z. Now x should be less than or equal to 7. This means this 2y should be less than 7. This means this y should be less than 7 over 2. And this 3z should be less than 7. This also means that z should be less than 7 over 3. Now what does these two conditions give me? That y will belong to the set 1, 2 and 3 and z will belong to the set 1 and 2 only. Now we'll put the values of x and y and z and we'll check the values. Now the first one is, if we take z as 1, y cannot be 1. The first thing is this, because we need to find out distinct triplets. So the possible values of y is 2 and 3. Now what are the possible values of the triplet, that is x, y and z? It will be 5, 2, 1, then 6, 2, 1, then 7, 2, 1, then 7, 3 and a 1. So how many distinct triplets are there? 4. 4 distinct triplets are possible. Now the second condition is when z is equal to 2. Then y is greater than 3 over 2z. From this equation we can write this. So y is greater than 3. But can y be greater than 3? No, because y only belongs to 1, 2 and 3, as we have already seen. So this condition is not possible. Z cannot be equal to 2. So how many total triplets, distinct triplets are possible here? Only 4 distinct triplets are possible here. So your answer will be option number D. I hope it's clear to you. Now we'll move to the next question. Now we have come to the 2024 54th question of the number system. So the question reads 32 to the power 5 plus 2 to the power 27 is divisible by which of the number? Now this 32 to the power 5 plus 2 to the power 27, this 32 can be written as 2 to the power 5 to the power 5 plus 2 to the power 27. It can be written as 2 to the power 25 plus 2 to the power 27. Now we can take the common factor outside. It will be 1 plus 2 square, which is nothing but 5. So we have, I can write it as 2 to the power 24 and 2 and a 5. I've taken this 2 outside, so it will be 10 times 2 to the power 24. So we have a factor of 10 here. So this sum gives me this, and it has a factor of 10. So this sum will be divisible by 10. Answer will be option number C. Okay. Now moving to the next one, that is the 55th question of CSAT 2024. Let P and Q be positive integers satisfying P is less than Q. I'll write it down. And P plus Q equals to K. What is the smallest value of K that does not determine P and Q uniquely? The first thing is to understand the question. Now if P plus Q is equal to some number, then P and Q will have values. Now suppose if P and Q, if we write P plus Q is 10, we can have different values of P and Q. We can have 5 and 5 also, but this does not determine the P and Q uniquely. So this cannot be the value of K. So this is the question. We have to find out the smallest value of K for which we cannot determine P and Q uniquely. Now, if K is 3, K cannot be 2, K cannot be 1 because they are positive integers. P and Q are positive integers. So K will have to be greater than or equal to 3 because P and Q are greater than 1, equal to 1. Now here P plus Q is 3. That means P and Q will be 2 or 1 or 1 and 2. So we can find out P and Q uniquely. Now if K is 4, it will be P plus Q is 4. So it will be 1 and a 3. Again, P and Q can be found out uniquely. If K is 5, P plus Q is 5. So we have 1 and a 4. P and Q can be 1, 4, 3, 2. And two values of P and Q would be possible. So uniquely we cannot find out what will be the value of P and Q if K is 5. So K is the smallest, so 5 is the smallest value of K that does not determine P and Q uniquely. So your answer will be option number C. Now moving to the next one. Let's read the question. There are 3 distinct prime numbers whose sum is a prime number. Now the question is asking what are those prime numbers, and 2 statements have been given to me. Now without using the statements we cannot solve the question here. Why? Because the question simply says they are distinct prime numbers and S is a prime number and we need to find out the 3 numbers. So definitely without using the statements we cannot solve the question. Okay. Now x plus y plus z is equal to S, where S is a prime number and x, y, z are also the prime number. Now the statement 1 says that S is less than 23. So what all possible values of S can be there? S cannot be 2, 3 and 5. Yes. Why? Because then x, y and z have to be 2, 3 and 5. So definitely the value of S will be greater than 5. So it will be 7, 11, 13, 17, 19, 21. S can take any of these values. Now if you look carefully, then the combination of x, y and z that will satisfy this condition is 3, 5 and 9 and no other value, and this will give me S as 17. So only one solution is there of x, y and z. So using the statement 1 we are able to solve the question. Now we will check for the statement 2. One of the numbers is 5. Let's assume that x is 5. Then we can write 5 plus y plus z is s. There is no limit on s. S can be any prime number, and we can find out infinitely many solutions for y and z to satisfy this condition. So no definite solution can be found out using the statement number 2. So we can say that this question cannot be answered using statement 2 alone, but can be answered using statement 1 alone. Now we'll read the options. The question can be answered by using one of the statements alone, but cannot be answered using this other statement alone. So answer will be option number A. We are able to solve it using statement 1, but we are not able to solve it using statement 2. Okay, now moving to the next one. We have reached to the 68th question of CSAT 24 paper, that is, and we are doing number system. Let's read the question. The question says x plus y is an integer. This is the question. These two statements are given to me. Now statement 1 says, definitely we cannot solve it without using the statements, so we'll check with the statement. Statement 1 says 2x plus y is an integer. Yes. Now let's assume that x is half, y is 1. Then 2x plus y will be an integer. It is 2, which is an integer. Now x plus y, our question is to find out x plus y. So x plus y will be 3 over 2, which is not an integer. So this does not help me get the answer. Statement 1. Statement 2. X plus 2y is integer. Here also we'll assume the values of x. Let x is half and y is 3 over 4. So x plus 2y is 1 over 2 plus 3 over 2, that is 2. It's an integer value. But x plus y, if we find out x plus y, it will be half plus 3 by 4, that is 5 by 4. It is not integer. Again, the statement does not answer the question. So we can say that this question cannot be answered using any of the statement. So if we read the options, option D will be the answer, because it says the question cannot be answered even by using both the statements together. Even if we use them together, we cannot answer the question. Fine. So with this, we have reached the end of our first part of the number system. We'll be continuing here from 2023 CSAT. We'll taking in the next video. Stay tuned and all the best for your exams.